Okay, so we're going to draw an angle in standard position and make a reference triangle to find cosine of 210. So we're trying to find what cosine of 210 is without a calculator, so we're going to make a reference triangle. So here we go. We're going to draw this angle in standard position. So 210 goes around here and then stops right about there. Now remember, our reference triangles are always going to be part of the bow tie. So that means our reference triangle goes this way and creates a right triangle here. And so this angle right here, let's see, we have 180, and then this angle right here is going to be 30 degrees. So since that angle is 30 degrees, we now know we have a 30, 60, 90. And what side is across from 30? Well, it's 1. Root 3 is across from 60. And 2 is going to be our hypotenuse. So what is cosine of 210? So here's our reference angle right here. So cosine is adjacent over hypotenuse. So adjacent is root 3 and hypotenuse is 2. And, guess what I forgot? That root 3 is negative because that's negative, and this 1 is also negative. So this is going to be a negative root 3 over 2 because remember, our x's and y's can be negative, but our radius, or our hypotenuse, is never negative. So cosine of 210 is negative root 3 over 2. You might remember that from the unit circle. Hopefully. Probably not. All right. So here we go. 315. So we're going to draw this as a reference triangle. And so 315 degrees is going to go all the way around here, and it's going to stop right about here. Because, 360 would be all the way around, but this is like 90, 180, 270, so it's going to stop right about here. And so then we draw a reference triangle to remind ourselves to figure out this angle. Okay, so reference triangle is part of the bow tie. So it makes a right angle here. So 315 to 360 is going to be 45 degrees. So there's a 45 degree triangle. That's a reference triangle. So the tangent of 315 is the same as the tangent of that reference triangle, which is 45. So this is a 45, 45, 90. And we know that the sides of 45, 45, 90s are 1, 1, root 2. And since this one right here is positive, that's a positive one, but this one's going to be a negative one. So it's going to be negative. And now we're asked for the tangent. Tangent is opposite over adjacent. So that's going to be negative 1 over 1, which is negative 1. So the tangent of 315 degrees is negative 1. Okay. Since 2 pi radians equals 360 degrees, it makes sense that 1 pi radians is half a circle, There's 2 pi's all the way around, 1 pi is half of the way around. Everybody gets all hung up on these radians, but really, like, pi radians is just 180, it's half a circle, okay? So here's some common measures, and we have to think about in degrees, so we're going to have to be able to go back and forth, okay? So, first things first, pi over 2, okay? If a whole circle is 2 pi, half a circle is pi. Pi over 4 would be 1/4 of a circle, right? Right, half of a half. Because if half of a circle is pi, pi over 2 would be half of a half, which would be pi, right there. Well, what's half of a half? It's half of a circle is 90 degrees. A fourth of a circle is 90 degrees, okay? The other thing you can do is you can multiply, but I'm thinking hopefully this is not too bad. Okay, so then what's pi over 4? Well, that's a fourth of the way, a fourth of the way to pi. And if all the way to pi is 180, half the way to pi is 90, a fourth of the way to pi would be 45 degrees. Pi over 3, same thing. Okay, all the way to pi is 180, so a third of the way, that's really not very good, but okay, a third of the way to pi, well, what's 1/3 of 180? That'd be 60, right? Because 60, 60, 60 would give us 180. So 1/3 of pi is 60 degrees. Okay, and then what would 1/6 be? If we made this into sixths instead of thirds, that would be 30 degrees. Okay, so now we're going to convert these ones from degrees to radians or radians to degrees without using a calculator. So 5 pi over 4. So there's a couple ways you can do this. Remember, pi and 180 are the same value, 180 degrees, and pi radians are the same. So to convert anything, we can multiply it by a conversion factor, and in this case, pi radians over 180 degrees, they're equal to each other. So we can multiply it either by this or 180 over pi, and we'd have to decide. Well, in this case, pi is on the top, so we want pi to cancel out, we want radians to cancel out, and we want degrees to stay. So we multiply this by 180 over pi. And then our pi's cancel out, and we do our math. Okay, so that's one way. Now here's a better way. 5 pi over 4 is the same as 5 times pi over 4, right? Okay. Well, what's pi over 4? Pi over 4 is 45. So this is the same as 5 times 45. And what's 5 times 45? Well, it's 225. So there you go. Either way, if we had done it either way, you would have gotten the same thing. That one's just faster. Okay. 270. Again, we could multiply this by pi over 180, and the degrees would cancel out, and we'd end up with radians. Or we can think about, well, 270 is the same as 3 times 90, because 90 is something that we know. We know that, like, off the top of our head. 90 degrees is pi over 2, so this is 3 times pi over 2, which is 3 pi over 2. Whoop, I always do that. Okay, negative 120. So again, we can think about this. You could multiply this by pi over 180 and do that math. Or you can think about this as negative 120 is the same as negative 2 times 60. And we know that 60 is pi over 3. So that's negative 2 times pi over 3. So negative 120 is negative 2 pi over 3. All right. We're going to draw an angle in standard position and make reference triangles to find these without a calculator. Okay, so the tangent of 5 pi over 6. So again, 5 pi over 6 is the same as 5 times 30, which is 150. Okay, so that's one way to think about it, because sometimes it's easier to think about them in terms of degrees. Or we can think about, well, 5 pi over 6 is almost 6 pi over 6, so it's almost a full pi. So it's not going to go quite all the way, but it's going to get close. So we're going to go right here. That would be 5 pi over 6, because it's like 1/6 of a pi away from a full pi. Okay. Then we draw a reference triangle. The reference triangle goes here. We're 1/6 of a pi away from a full half circle. So that's pi over 6, or 30 degrees. Okay, and then we want to find tangent. So what's a 30, 60, 90? Well, this is a 30, 60, 90, so that's 1, 2, root 3. And tangent is opposite over hypotenuse, so tangent of this one is going to be, well, this is a positive one, that's a negative root 3, so it's negative 1 root 3. And we can put the negative with the root 3. It's just, I just hate putting negatives in the denominator. It's not really kosher, I guess. We don't do that. So it doesn't really matter where you put the negative. With the 1, with the root 3, outside, it's all the same. Okay. Cosine of negative 3 pi over 4. So again, I'm going to think about this in terms of radians instead of trying to convert back and forth between degrees. I'm just going to think about 3 pi over 4. It's almost 4 pi over 4, which would be almost a full rotation. So I'm going to go this way. So it's going to be right here. And then I'm going to think about that. So I make a reference triangle that's part of my bow tie. And what do I have left? I have pi over 4. That's a pi over 4 in there. Okay. Now pi over 4 is the same as 45. So this is a 45, 45, 90. So it's 1, 1, root 2. I know it's like I say I'm going to not think in terms of degrees, and then I end up thinking in terms of degrees, but it's hard not to. but it's good to try to get out of the habit of always having to convert to degrees and actually just knowing them in radians, okay? So cosine is adjacent over hypotenuse. So let's see, this one is negative and this one is positive because it's a hypotenuse. And this one is negative though, right? Because the x is negative and y is negative. So cosine of this one is going to be negative 1 over root 2. And that's it. Okay, this one, 5 pi over 3, so that's bigger than 1, right? 5/3 of a pi. So I'm going to go 1 whole pi. Okay, and then 5/3 of a pi is going to keep going. It's going to be past another half of a pi. It's going to be right about here. I'm going to be 1/3 of a pi away from 2 whole pies, right? I'm 5/3 of a pi. I just need 1 more third, and I would have 6/3 of a pi, and then I could have 2 pies all to myself. Okay, so I make my reference triangle here. Okay, and so then what is this? That's 1/3 of a pi, so it's pi over 3, or 60 degrees. Okay, and so this is a 30, 60, 90, so this would be across from the 30 is 1, across from the 60 is root 3, and across from the 90 is 2. And again, this 1 is going to be positive, but that root 3 is going to be negative because it's in the negative y. All right, so then it asks for cosecant. Cosecant is 1 over sine, or the reciprocal of sine. Okay, so sine is opposite over hypotenuse. So cosecant is hypotenuse over opposite. So hypotenuse is 2. Opposite is negative root 3. So my cosecant equals negative 2 over root 3.